Math 321, day 12, lecture day 10. I think, well, I hope we finish up chapter 5 today. Today we're talking about linear inequalities. Previously, we solved questions like 2x plus 1 equaled 3. And we solved them by subtracting 1 from both sides here and getting 2. And then dividing by 2, and we get x equals 1. That's an equality. If we do a linear inequality, this is something like this. 2x plus 1 is less than 3. And the steps are the same, almost identically. Almost identically the same steps. And in some cases, the exact same steps. Like here, it's going to be the exact same steps. I'm going to do the same thing. I'm going to subtract 1. And I will have 2x is less than 2. And then I divide by 2, and I get x is less than 1. The only difference here, this had a single answer. The single solution on this one. Here, there's an infinite number of solutions. We could still do our little number line, 0 and 1. Have the plus infinity and minus infinity on there. And we can do our pin from left or we can do the picture. Put a circle above the 1 and then draw the arrow left. And so I think like the homework, when you do it on the homework, it'll put the circle right on the 1 and then shade left. That's how it likes to do it. I think it makes it a little bit harder to read, but they use, when you're doing it by hand, it's easier to read if you draw it above it. But if we did our interval notation, we start at negative infinity, and we go up to 1, and neither one is included, so we got negative infinity to 1. In fact, these are exactly identical to the steps for linear equations. We just add 2 new rules. And that's because they apply only to the inequality symbol. And by linear inequalities, I mean they will have symbols like less than or equal to, greater than, or greater than or equal to. Not the equal sign. chance to finish writing that, and then I'll talk about the two rules and illustrate them. I'll give examples using numbers first to motivate the ideas. Does anyone need this a little longer? If you do, raise your hand. Okay. So I'm going to just draw a quick number line real quick. We'll have 0, 1, 2, 3, -1, -2, -3. What symbol should I put between 3 and 1 if I do this? How does 3 relate or compare to 1? Is it less than? Is it greater than?
Greater.
It's greater than. Okay, so what way does the alligator face? It faces towards the 3. Alligator always chases the bigger meal. Always. You can bet your bottom dollar on it. The bigger the meal, the longer it has until it needs to find another meal. So I'm going to do two things that illustrate the two rules. What happens if I switch the sides? What if I put the 1 on the left and the 3 on the right? Now which way does the alligator face? It's still towards the 3, right? But now this says 1 is less than 3. And this up here said 3 is greater than 1. What? It does mean the same thing, but right now that's important to recognize. It means the same thing. Keep that in mind. What if I make them both negative? What if this says -3 and -1? Which way does the alligator face now? For the -1, right? The -1 is now the larger or greater meal. -3 is less than -1. There are two reasons why the sign will flip directions. Why the inequality sign flips directions. Because that's what it did, right? It was greater than up here, and it's flipped directions here. If we just swap which side stuff is on without adding or subtracting. You might do this if you like using the little arrowhead, like the symbol looks like an arrowhead. What if I had like 2 is less than X? The little arrowhead thing symbol doesn't work unless X is on the left. So if I switch this and put X on the left and 2 on the right, and I didn't add or subtract anything, the alligator thinks X is the bigger meal. The alligator still thinks X is the bigger meal. So I just swapped which sides they were on because it makes it easier to read. That's the only reason we ever swap sides, is because it's easier to read. There's no mathematical reason to do so. Okay. So this one only happens if you like reading it with the X on the left and you add X on the right. Or vice versa, if you're a psychopath and you like your X's on the right. I won't judge you too much. Just a little. Then B is if we multiply or divide by a negative. Negative number or value. So if I had y is greater than or equal to -1, and I multiply both sides by negative, well, let's start this the other way. Let's say negative y is greater than or equal to -1. That would be more of a reason why I would do it. I don't want the negative sign in front of the y, so I can multiply by -1, or I could divide by -1. But this is going to make this a positive y. This is going to make this a positive 1. And now the alligator has got to flip directions. Kind of like the same reason up here. What I did going from 3 is greater to 1 to -3 is less than -1 is I multiplied by -1. So for the same reason that that one switched, this one switches. The hell? What the hell is the minus for? So let's look at an example. Do anyone need this up longer? $2x minus 6 is less than 3 times x plus 1 minus 5. So we're going to treat it like it's an equal sign. The only reason to change the sign is the 2 reasons we just said. If we swap or do multiply, divide by negative. Just stay on the lookout for that. So what we would do here first is we would distribute that 3. Which means multiplying the 3 times the x. And I get 3x. And I multiply the 3 times plus 1 and I get plus 3. Then I see two numbers on the right. I'm going to combine them. 3 minus 5 is -2. All right, so we've got two paths forward. Move x's left. Or we'll move x's right. That should say left. That looks like a fucking crazy person was learning how to write. All right, so let's say I move the x's left, which means I have to subtract 3x from both sides. And even though I'm subtracting a 3x, there's a negative sign there. I'm not multiplying or dividing by a negative, so I don't do anything about that. Now I can add 6 to both sides. And I get -x is less than 4. Finally, if I want to divide by -1 or multiply by -1, it does the same thing. The x becomes positive, the 4 becomes negative, and we have a direction flip on the inequality symbol. Okay. And if you're not sure, you're like, I don't remember what goes on, like just check a number here. I had -x is less than 4. So what if I had like -1? -1 is less than 4. And if I change the sign, this becomes 1 and this becomes -4. And I can see that the alligator's got to go left. So you can always like throw something in and do a quick check to go, if in case you don't remember, like, or you're unsure. It's more like unsure. Should I do it here or not? You can always do this even when you don't have to switch sides. If you change the sign, you can see what happens. All right. Here, I'm going to move the x to the right. So I'll subtract 2x from both sides. And I have -6 is less than x minus 2. And then I can add 2 to both sides. And I get -4 is less than x. But if you're drawing a number line, like I've got a circle on 4. Like this is a little fuzzy. Which way? I don't know which way. Like it's hard for me to read. -4 is less than x. My brain doesn't work like that. It just doesn't. But, and you can notice that the alligator is pointing at the same thing as that one over there. It's pointing at the X. So if I want it in a way that I can read it, I'm just going to switch the sides. I'll put the X on the left, the -4 on the right, but since I switched the sides, now I can say X is greater than -4. I go, oh, all my numbers are bigger than the target number. Bigger than the target number means they're that direction. Also, by moving it to the left, I can treat this as an arrowhead. It doesn't work if I try to do it up here. When X is on the right, the arrow is pointed in the wrong way. You guys ready to try one on your own? And then we'll do it together? I have faith in you guys. You guys can do this. -4n minus 3 is less than 9. Solve that through and then we'll do it together. Is anyone done? Is anyone not done? If you're not done, raise your hand, I'll give you longer. Or you're not doing it, one of the two. All right, you said you're done. What'd you do? Yeah, I'm gonna make you talk.
I added the 3 to the 9.
Okay, I like that. This works for me. You got 12? No, what?
And then I subtracted the 4.
Like that?
Yeah.
Okay, that we can't do. So, we don't want to do that. I'll show you why in a second. Instead, this is multiplied by it. So we want to do the opposite of multiplying. What's the opposite of multiplying?
Divide.
Divide. Let's divide. And I will get n over here, and I will get -3 over here. And the sign flips direction. Did you flip the sign when you subtracted 4?
No, I think I actually said it wrong. Like I divided by -4.
You divided by -4?
It said subtract -4.
Okay.
Yeah. I don't know.
Okay, that's fine. You said the wrong thing.
Yeah.
Well, yeah, I saw -4 underneath it. Totally looks like subtracting 4. I get it.
Yeah.
Totally looks like subtracting 4.
Would you divide the n and negative to the 1? Like afterwards? Or would you just leave it that way?
Dividing it by 1 doesn't change the value.
Gonna do it.
Yeah, like put it in a calculator, 5 divided by 1, it's still 5.
Yeah.
So there's no I mean, if you want to make it look like a fraction, you can. You could write this as n over 1 is greater than -3 over 1, but that doesn't change anything. Another way of doing this, if you don't it's easy to forget the negative and what's going on. So another way to do that is add 4n to both sides. And I get -3 is less than 9 plus 4n. Subtract 9. -12 is less than 4n. Divide by 4. And I get -3 is less than n. And then I go, I don't like seeing n on the right. I'm going to put it on the left. And the alligator is still chasing the n. And then you avoid, because it's easy to not divide by the negative. Just forget about the negative, divide by 4. And then you wouldn't change the sign. There'd still be a negative there, but you probably won't even write it because you didn't forgot about it. Ready for more? We'll do 2 more and we'll be done. Go ahead and work on that one. Too easy. I can make it harder.
No,
Are you sure?
I don't know if I did this one right, but I think.
You don't want me to call on you, Michaela? You sure? Did you even try it?
Yeah.
You at least tried it, okay. That's all I can ask. Like, if you don't try it, what's the fucking point if you show it
I
up?
think it's good, but. At first I forgot the negative. The negatives to do.
Alright, so. Is anyone feeling brave? We already know you're not feeling brave. You feeling brave?
I mean, like the first part,
Let's go for it.
I did -4 times x and then times 6.
And what'd you get when you did that?
I got -4x and then minus 24.
Okay, and we should still have the plus 18. Everything else stays the same. Notice even the shit I don't change, I keep writing down. It makes it a hell of a lot easier to keep going. If you just wrote down -4x minus 24, it's really easy to lose stuff into the fucking space of the white space of the page. Like, don't be a lazy fuck. Write this extra shit down. All right. What'd you do from here?
And then I added the, I guess, -24 plus 18,
And what'd you get?
and I got -6.
Okay.
And then this is where I don't know if I'm right. I just added the -2x to the -4x, but. I don't know.
So when you say added, like just like did that?
Yeah, and then I
Okay.
put it on the other side.
Okay, so you added to get rid of the -2x. What'd you get from here?
I got -2x minus 6. And then, I don't know, like,
Adding and subtracting doesn't change the sign. You're still good.
okay, and then +6. And then from there, I just added, what did I? Oh, yeah, I added -6. Well, I changed it to a positive,
So you added the opposite.
yeah,
Okay.
and then I got -2x. Is less than.
That's the greater than sign.
I mean, okay,
That sign?
where am I?
Did you have that sign?
Yeah.
Okay,
and then-
That's the greater than sign.
Okay, and then, am I supposed to switch it, because that's not right, is it? Like,
Everything is right so far.
okay, and then I just divided by -2 on both sides, and then.
And what'd you get? What's your final answer?
X is less than or equal to -6.
Like that?
Yeah.
That's correct. Yay! Good job. You're all
I
super
remember-
nervous about
I
it.
remember this.
All right, now write it in interval notation. Hopefully you've seen all of this before in high school, hopefully. So pictorially, I have a circle on -6 and I fill it in because it's equal. And since I have X on the left, it acts as an arrowhead. It's pointing in the direction I want. You don't have to do the number line, but sometimes I think it is easier to draw the interval notation if you do. Which means that going left to right, this starts at -infinity. It ends at -6. Infinities always get parentheses, and the solid points or the things that have an equal to portion get a bracket. Okay. One final thing. One, the easier way that Michaela's gonna hate, and one, the more tedious way that Michaela's like, this will be easier. We're gonna do it both ways. If you need that up longer, say something. I just fucking elbowed the keyboard. 4/3 x minus 2/3 is less than or equal to 4/5 x plus 3/5. So we got fractions. What does Hefe say to fractions? Fuck them. Fuck fractions. So this is the math way. And that means get rid of them. We want to tell them to fuck off and get out of our equation. The only way to do that is to multiply by the LCD. Or multiply by a common denominator. We've done a lot of work with the fractions though. How do we get a common denominator? Or what is the common denominator? So, when all else fails, multiply. This is pretty easy because I only have two different ones. I don't need to multiply them all. I don't need to do 3 times 3 times 5 times 5. Just 3 times 5 will be sufficient. Three times 5 equals 15. I'm going to multiply everything here by 15. And if it helps, I can make it 15/1. And I'm gonna put that minus sign right there so it shows up a little bit better. Because that's starting to look like a fraction. Okay, instead of putting 15, you can actually put 5 times 3 on each spot, and it might be easier. Because then whatever shows up in the denominator, you just cross out. So I can cross out the 3's here. And that's going to leave me with 5 times 4x. And I can cross out the 3's there, and it's going to leave me with 5 times 2. I can cross out the 5's here, and it leaves me with 3 times 4x. And I cross off the 5s there, and it leaves me with plus 3 times 3. So we have 20x minus 10 is less than or equal to 12x plus 9. You do a little bit of fucking crappy work in the beginning. The rest of it is easy. So I can subtract 12x from both sides. And I get 8x minus 10 is less than or equal to 9. I can add 10 to both sides. And I get 8x is less than or equal to 19. And then I divide by 8. And I get x is less than or equal to 19 over 8. Which is a shitty looking number, but it's a number nonetheless. And it works. That's the answer. But I'm absolutely certain Michaela started tuning me out when I said common denominator. She's like, fuck all this. I hate math. Right? Kind of. You wanted to tune me out, but you didn't.
I got lost, so I stopped writing it down.
Okay, so Michaela might like this. There's another way to tell fractions to fuck off, and that's to turn them into a decimal. 4 divided by 3, you put it into a calculator. I recommend doing like several decimal places. Because you don't know how many you're going to need to round to on the end. And you want to work with more decimal places than you need to round to. So all I've done is turned all those fractions into decimals. And now fractions are already gone. They can go fuck themselves. That's right. Bye, bitch. Right? And now I can go about doing it the way I would do normally. I can subtract. It sucks working with decimals, but it's just a number. And I'm going to make my calculator do it all anyway, so fuck it. Why not? Why not do it? This should give me, I don't know, if I subtract 0.8, 0.5333, bunch of 3s, and an x, minus 0.666666667. Someone have like a fucking like great moment. What was that?
Oh, Del Diablo.
Oh, the devil. Pleased to meet you. Won't you guess my name? Then we add the shitty constant, get it just add the number to the other side. I don't know. And I get 0.5333333333333 x is less than or equal to 1.266666667. And if I divide both sides by 0.5333333 blah blah blah. I will get x is less than or equal to, where is my trusty calculator? 1.2666667. I'll do 6 decimal places. Divided by 0.53333. I get 2.375. And then a lot more decimal places. 0, I got a couple zeros and then some more junk.
Would those matter? Like, do you have to put those in there?
Depends on what your answer wants you to round to. What is 19 divided by 8? Exactly 2.375 with no extra stuff. There was a 2 and some other stuff. So by going to a decimal, I inserted some error, like I had more stuff, I wasn't exactly 2.375. But if you do enough decimal places here, the error won't show up in the digits you care about. And then you can avoid working with fractions.
That's harder.
All right, there we go. I wasn't sure how that was, wasn't sure which way that was gonna land, and I thought, you know what? Let's show Michaela how to do it this way.
I mean, you can probably check your work that way though. Like if you did it that way, to see if it was the same as your first one.
Oh yeah, well, you can also always check your work by going in and plugging your answer in up here. And if you, like, I would probably do that in a calculator. But if you plug it in, you're checking for equality, not less than or equal to. That's it for chapter 5's support shit. On Tuesday, we'll start chapter 4 support, which we're not actually covering till after the midterm. So you're golden for a little while on the support stuff.
When's the midterm?
Soon.
Like in soon.
I don't know, let's look.
You know, have on it.
As many as I possibly can. Just for you.
You told us we could have a flashcard.
I did. You know what? I don't give a shit. Flashcards so rarely make a fucking difference.
Did you say the midterm we got notes?
No,
Flashcards.
Oh, was it the flashcard only?
I'm sure I didn't say notes. No, I might have said notes because
It's on the final is when you said you could have a flashcard, but I think on the midterm you could have our notes.
I think you're trying to fucking Jedi mind trick me right now. Is what I think.
Who said no?
There's no such thing as a Jedi mind trick,
There is two.
not really.
It's called gaslighting.
I'm good at deception.
It's called gaslighting in modern America. It's the fucking Jedi mind trick in the Star Wars universe.
I'm not very good at deception, I'll find that out very quickly.
Thursday, October 5th. Dun dun dun.
So we get to have notes?
Yes.
I didn't, what the fuck? I didn't say shit.
Bacon, I have it written on my paper.
It's on my notes.
I have it written.
Ooh, got him.
You said it August 31st at 4:52. We can use our notes on the midterm.
Timestamp. Let me see the fucking timestamp.
Timestamp and everything.
Don't be saying certain a timestamp right now. Leave it as it is. Quit fucking with it.
Right there.
I did say the password is bacon. That is something I would have said.
See, I knew the password was bacon.
I didn't hear you say that. I didn't hear you.
See, now you got like.
No, I really didn't hear her say that right now. I was busy trying to fucking bring it up, and you guys are dazzling me with fucking questions.
Will you have like a study guide or is it gonna be?
We're gonna have a whole day of review.